So, we also talk about the light environment in the canopy, and this is related to the Beer-Lambert law. Beer-Lambert law says that as you go down into a canopy, so this is the top of the canopy, as you go down into a canopy, the amount of light that you'll see declines as a negative exponential. That's what a negative exponential looks like. So it declines really fast at the top of the canopy. Then underneath the canopy, it can be really quite dark in, for example, some rainforests, where you have a really thick canopy. And what we mean by thick or thin canopy is really the leaf area index. And so I'm showing you a couple images, one where there's a lot of leaf area index, and the other where there's not so much. Leaf area index is the area of leaves that you have over a given area of ground. So let's say you had a 1 square meter leaf that's perfectly flat and horizontal over a square meter of ground. That would be an LAI of 1. So it's basically how many leaves you're stacking up above the ground. And these are a bit out of order, so now I'll come back to the total energy budget. So we can do an energy budget for a leaf. We went through that in detail during the lecture. We can also have an energy balance for the globe. So energy balance leaf, energy balance ecosystem, energy balance globe. On a global scale, we actually do pretty good at closing the energy balance. So basically, our incoming energy is downwelling solar radiation and downwelling thermal radiation. So solar radiation from the sun plus radiation from the atmosphere. And that has to equal the reflected sun, so reflected due to albedo, the emitted long-wave thermal from the ground, the latent heat flux. Latent heat flux, remember, is your evaporation and transpiration, evapotranspiration. Sensible heat flux is just heat. It's heat that you can feel, thus sensible heat flux, and ground heat flux. So there is a bit of heat that goes into the ground. Not a lot, but a bit. And so when you take your source terms, your incoming terms, they equal your outgoing terms to about 1 or 2% on a global scale. Now to dry lands. So dry lands are hyper-arid, arid, semi-arid, and subhumid ecosystems which are characterized by low precipitation, low soil water availability because of low precipitation, low photosynthetic rates, and low hydraulic conductance. I just jumped one. Low soil water availability, low evapotranspiration, which is what we're showing here. In Australia, high sunlight, low humidity, and high vapor pressure deficit. So this combination of terms means that we have very low evapotranspiration because of the low precipitation, low soil water availability. And we have high potential evapotranspiration because of the high sunlight, low humidity, and high vapor pressure deficit.